So here's a real quick demonstration of Young's double slit experiment, the classic demonstration of wave interference with light. We have this ancient 1980s style red laser, and it's shining through a little slide that has tiny slits in it. Okay, and it's good to use a laser because the waves are synchronized. In other words, they're coherent, and they're also monochromatic, which means they have the same exact wavelength. And so we're projecting this laser light through these two holes onto a screen, and you can see that the screen shows bright spots and dark spots, alternating bright spots and dark spots. The bright spots are where the waves are hitting the screen peak to peak and crest to crest. Well, peak to peak is the same as crest to crest. Peak to peak and trough to trough. The dark spots are the really interesting bits, though. These are the places where the waves are exactly out of phase with each other. In other words, the crests and troughs are meeting at the same place. So the crests of the wave going through one hole is meeting the troughs of the wave going through the other hole. And what we have is interference and total cancellation. So if you were a tiny being the size of a flea or a tick, perhaps, sitting at one of those dark spots, and you had little tiny binoculars looking back at the laser beam shooting through the holes, you would see no light at all coming through those holes, even though the light is coming through both holes, because the light from the left hole is actually canceling out the light from the right hole. And that's what I find fascinating about the double slit experiment.